Alright, hello and welcome to Bookkeeping Mathematics. My name is Al and I will be that little voice in your ear. Feel free to mute me and put on closed captions. Today we're going to be talking about perpetuities. I know, very exciting stuff. So a perpetuity is a type of annuity in which the periodic payments begin on a fixed date and they continue indefinitely. So unlike regular annuities where there's a fixed beginning date and a fixed end term date, perpetuities just perpetually carry on, payments being made and interest being gained. So since there is no end to the term, it's not possible to determine the future value of a perpetuity, such as with an annuity. So what you have to end up doing is taking the present value of a perpetuity and using that as a definite value. So in terms of finance, perpetuities do not have future values, but the present value is a definite value. So you're probably wondering where you're actually going to ever come across perpetuities in accounting and finance. And in one way you'll find them is in interest payments, more or less on permanently invested sums of money. That's a prime example. Another one would be dividends on preferred shares. Those fall into that category, assuming that the corporation issuing the perpetuity has an indefinite life. Another example is scholarships, which are paid perpetually from things like endowments, and they'll fit the definition of a perpetuity. So again, it doesn't mean it lasts forever, but the idea is that it will indefinitely continue and there is no fixed end term. So when you're working with just ordinary perpetuities, there's four different kinds of terms, in algebra that you use for them. So what you have to start is you have PV, which is your present value, right? You should, oh, okay, this might not be the way to go. Okay, well, it's your present value. Then you have your payment, and the payment is the periodic payment, the periodic rent, or a perpetuity payment. It's just the payment that you make or the issuing party makes. There is also the interest, which is what the money is going to gain on. And of course, there is the effective rate of interest. Okay, so I should back up. This I is actually the rate of interest per the conversion period. So we're talking, 12 months, we're talking 1 year, we're talking 6 months. But in terms of perpetuities, we're generally just always using them on the basis of 12 because it's compounded. If you compound monthly, I guess that's what I should say, is that this interest rate is compounded. And it's based off of how you compound. So then P is the effective rate of interest per the payment period. So what P actually equals is 1 plus I to the power of C minus 1. And what C is C is, hold on a second here, I know what C is. C is the conversion rate. Oh, I should have known that. C is the conversion rate. So that's the four terms that you have: PV, PMT, I, and P. Okay, so now what we're dealing with here in this example is, okay, so how we're going to do this, hold on a second here. Okay, so if you want to see kind of how that formula breaks down, it's pretty cool. So what you end up having is the present value to n terms equals the payment times 1 minus 1, what's 1 plus the interest to the power of the inverse terms over the same interest, okay? And what this determines is the present value of an ordinary simple annuity. And this is the formula that calculates it. It breaks down the formula as n increases and approaches infinity. The factor 1 plus I to the power of n inverse approaches 0. So thus, the formula for finding the present value of an ordinary simple perpetuity becomes PV equal to payment over interest. I should have said present value equals payment over interest. So that breaks down to then the simple ordinary general perpetuity formula, which the payment is the interest earned by the present value of the perpetuity in one payment interval. So that is to say, the payment is equal to P, which we determine to be the effective rate of interest per the payment period, times the present value. So thus, the formula for finding the present value of an ordinary general perpetuity is present value is equal to payment over effective interest rate, where again, P is equal to 1 plus I to the power of n inverse. Okay. Oops. Let me get rid of this again. So let's do an example before I try to get a boredom. Okay, come on, this is exciting. Math and finance, you gotta love it. All right, so one way that you can look at this, because perpetuities differs from an ordinary perpetuity only in the first payment as it's made at the focal date. So therefore, a simple perpetuity due may be treated as consisting of an immediate payment followed by an ordinary perpetuity. So the formula for finding the present value of a simpler perpetuity due, remember, is different than the ordinary perpetuity due. So is PV, which is present value due, equal to payment plus payment over interest. So a general perpetuity due can also be treated as consisting of an immediate payment followed by an ordinary general perpetuity. Using the symbol present value due for the present value, the formula for finding the present value due of a general perpetuity due turns into becoming present value due is equal to payment plus payment over P, where P is equal to 1 plus I to the conversion rate minus 1. Okay. Okay, so now that we have that figured out, why don't we actually do an example? And we can do it in 5 minutes. So let's say that a tract of land is leased in a perpetuity at $1,250 due at the beginning of each month. And if the money is worth 7.5% compounded monthly, what is the present value of the lease? Well, first of all, let's just write down what we know. We know that payment is equal to $1,250, and we know that interest is equal to 7.5% over 12 months, because remember, it's compounded monthly. Okay, so what we do is we do the math of 7.5% divided by 12, which equals 0.625%. Otherwise, in decimal form, 0.00625. And that now is our interest rate. So when we do our formula, it's very straightforward, as present value is equal to 1250 plus 1250 over the interest of 0.00625, which in turn equals 1250 plus 200,000 to equal $1,250. Okay, so now that we have that information, and remember, this is your first focal payment. This is where it all starts, and this is where it continues. Okay, so moving on. we want to know now, what is the present value of perpetuity payments of $750 made at the beginning of each month if interest is 8.5% compounded semi-annually? Okay, so this is now a little bit different because now what we want to know, for 7-8 minutes of talking, that was all there was, is you have a two-term formula that brings you back what it is now due. You just got to figure out your interest. So let's quickly try another one. So what is the present value of perpetuity payments of $750 made at the beginning of each month if interest is 8.5% compounded semi-annually? So again, let's write down what we know, that the payment is $750, that the conversion rate is 2/12, which is equal to 1/6, which means that our interest is 8.5%. They're not exactly correlated, but they are, divided by 2 is equal to 4.25%, which in actual terms gives us 0.0425. Okay, so the equivalent semi-annual rate of interest is P equals 1.0425, because remember it's 1 plus interest to the power of 1/6, because it's to the power of C, minus 1, which ends up equaling 1.006961, otherwise known as 0.6961%. Okay, so now that we know these things, we can do our present value due, as we had talked about. So this equals 750, there's our payment, plus our other payment, because remember this is the start of our focal date, which is how you would want to do it anyways. And this is our interest rate, well, our P, where P is defined as our effective interest rate. And this equals our 750 plus 750 divided by 0.006961, which is payment plus payment over P, equals 108,492.18. And that is what the present value of the perpetuity is. So there you have two quick, rough examples of how to determine the present value of a perpetuity due. Now, you can carry on with things like deferred perpetuities, but for today, we're just going to stick with ones that are due now. Thanks for joining in, and I will see you later.